Welcome back, student. Today we are going to see the Ndfa or NFA. Okay, so this is a lecture 4. Before this, just we will go back and quickly see what we have done. Okay, so here the main thing is finite automata. Finite automata can be classified into two, as I told you in the last class. And first one was a DFA, deterministic finite automation, and non-deterministic finite automation, NDFA, or you can say NFA. So in the last class we completed this, okay, and we saw some of the examples. And today we are going to see the Ndfa, okay, or NFA. So before that, first we will see what is the DFA. The DFA is each input symbol one can determine the state to which the machine will move. Okay, there is a deterministic automation, and this is a deterministic finite machine, a deterministic finite automation. Okay, so this is a DFA, and here the 5 tuples are there. As I told you, if you have a FA or DFA or NFA, okay, this 5 tuples will be there. First one is Q, capital Q, sigma, delta, Q0 and F. Okay, what is the Q? Q is a finite set of states, and sigma is a finite set of symbol called the alphabets. Okay, and here delta, sorry, yes, and how the Q will be represented here? Q is equals to, like example, A, B, C. Okay, and sigma is equals to 0, 1. Okay, delta is a transition function where delta Q cross sigma. Okay, Q cross sigma. Q0 is the initial state from where any input is processed. Q0 belongs to capital Q. So how the initial state will identify with this Q0 state, and this is a empty processing input to the any one of the state. There is a initial state, remember that. And F, what is F? F is a set of finite set and states, finite state or states of Q, F subset of Q. So how can you identify the final state? Double circle. This is a double circle, and this you can identify with graph, transition graph. In transition graph, if the any empty string, any empty R is given to any state, there is an initial state, and if any state has double circle, that is a final state. Okay, and we saw we took the example in the last class. Q is equals to ABC, sigma 0, 1, Q0 is equals to A. What is Q0? Q0 is a initial state. Okay, and what is capital F? Capital F is C. What is C? Final state. Okay, so we have the Q, yes, we have the Q, we have the sigma, we have the Q0, we have the QF, final state, but we need to do the delta. We need to do the delta function. Transition function is delta. Delta is capital Q cross sigma. You can see here in this process state, this is a Q, okay, and sigma. So this is a cross Q cross sigma, this and this. So this is called transition table and this is called transition graph. Okay, I will change the color to dark blue. Okay, so this is called transition table and this is called transition graph. With the help of, while seeing this transition table, we can make the transition graph. Okay, how? Just quickly I will tell you. This is initial state, okay, A. How many Q's are there? A, B and C. Okay, and how many sigma is there? 0 and 1. So let's see. A is going to A when the input is 0. A is going to A, okay, A is going to A when is 0, input is 0. Okay, in the same way A is going to B, A is going to B when the input is 1. So this is a input is 1. Okay, in the same way B is going to C, B is going to C when the input is 0. B is going to A, B is going to A when the input is 1. B is going to A, B is going to A when the input is 1. Next, C is going to B, C is going to B when input is 0, is going to B when the input is 0. C is going to C when the input is 1. Okay, so this is a final state and these are the normal states and this is the initial state. Okay, so this is a last class discussion, just I did the quickly review. Okay, and this is a like same thing, we took the example, we took the transition table and we draw the transition graph or state graph. Okay, so with the help of this you can draw. Okay, and after that we saw the given string is accepting or not. That also we saw with the help of example. Okay, this example is here, so if you see the previous video then you can easily understand this concept. Okay, so we saw the acceptance of string by finite automata. Next, so in today's class, okay, in today's class we are going to see the NDFA. Okay, fine. What is NDFA? Non-deterministic finite automation. In NDFA, for a particular input symbol, the machine can move to any combination of the states in the machine. Okay, any combination of the state in the machine. In other words, the exact state to which the machine move cannot be determined, hence it is called non-deterministic automation. Okay, so for this real-time example for this NDFA, then it will be easy for you to remember. Like take the example of var. In the example is var and politics and we can say the sport, we can say the sports, okay, and lottery, this all etc, this all will come under NFA. So here can move to any, here what is this, for a particular input symbol the machine can move to any combination of the state is the machine. Take the example of lottery example. So here it will take one input and it will search all the combination and we will get the result, and the result is not deterministic. In other words, the exact state to which the machine move cannot be determined. We cannot determine which number, which lottery number will going to be final. Okay, that is called non-deterministic automation. As it has finite number of states, the machine is called non-deterministic finite machine or non-deterministic finite automation. Okay, so this is a NDFA. I hope you understand this. Like NDFA, it will take as input symbol. The machine can move to any combination or different combinations, and we will get the answer. After that we will get the answer. So we took the example of this all are the example of NFA: war, politics, sports, lottery. Okay, this all are etc. This all are come under in NDFA. Okay, next one is same thing, formal definition of a NDFA. Here also we have the 5 tuples. Okay, in DFA and NFA both has the 5 tuples. Okay, what are the 5 tuples? Q, sigma, delta, Q naught and F. Here Q, sigma, Q naught, F will be same, but the delta is little bit different here. NDFA, what is the thing? See, Q is a finite set of state as we study in DFA. Sigma is a finite set of symbol called the alphabets. This also it is same as DFA. Okay, this both same as DFA, same as DFA. Delta, okay, delta is a transition function where delta Q cross sigma implies 2 power Q. Here the power set of Q is 2 to the power of Q has been taken because in case of NDFA, from a state transition can occur to any combination of Q state. Okay, what is in the DFA? In DFA we will have Q cross sigma is Q. Okay, but in NDFA or NFA, in NFA Q cross sigma is 2 to the power of Q. Okay, and what is this? Because here any combination, because of that any combination is nothing but whatever we have the finite set, this many combinations possible, because of that we are writing 2 to the power of Q. Okay, and in the Q example, if we have Q is equals to A, B, C, so this many alphabets possibilities are there, 2 to the power of Q. Okay, and here Q0 is the initial state, same as DFA. Okay, same as DFA. F is the set of finite state or states of Q, F subset of Q. Here also this is also the same as DFA, but the major difference is this one. Major difference is this one, that is a delta. Okay, remember this. This is very important. If you understand the DFA and NFA, then it will be easy for you to do the problems, okay, to do any kind of examples. So this is a formal definition of NDFA. Okay, so here, okay, now graphical representation of an, sorry, here it should not be an, okay, graphical representation of a NDFA. NDFA is represented by digraph called state diagram or transition diagram. Or mapping. There are so many names are there. Okay, state diagram, transition diagram, mapping. Okay, so anyone you can, if you see any one of the name, that is state diagram, transition diagram and mapping. Okay, the vertices represent the state. What is the vertices? We are drawing the graph like Q0 is Q1. So this is, what is this? This is a vertices and this is called state. Okay, and this is the initial state, this is the final state if we go like this. Okay, and one more thing, you can make Q0 this and this. Here in this is a initial state first. Okay, initial state, and this is a final state. This is possible. Okay, sometime the initial state is a final state sometime. Okay, this is also a valid. Okay, the arcs label with an input alphabet shows the transition, like here 0, and if here is 1, here is 1, here is 0. Okay, so whatever it is showing, it is labeled. The initial state is denoted by a empty single incoming arc. Okay, empty incoming arc, only a single, double should not be there. Okay, so here if you forget to draw in the state diagram this initial state and final state, if you forget to define the initial state and the final state, then your whole diagram will be wrong. So this is very important. Don't forget the initial state, don't forget to show the final state. These two are very important. Okay, important. These two. Final state is denoted with double circle. Okay, this is very important. Next, so now we will going to take the example. Okay, let's a non-deterministic finite automation be. First one is, so what we have Q sigma delta Q0 F. Okay, so what is the Q? ABC. Sigma is 0, 1. Q is A. F is C. So this is a initial state. and this is a final state, and this is a alphabets. Okay, and this is a finite set of symbols. Okay, finite set of symbols. Okay, now we need to see this input. Here we need to see the transition table, so we need to change the color. Here blue color is there, so click on the red here. Okay, what is this? This is a transition table. Okay, in the transition table, and this is a transition graph. After telling you what is DFA and NFA, then I will show you the differentiate. I will do the differentiate between DFA and NFA. Okay, so now first we will see this. Okay, what is this? A is going to 0, so what is the answer? So here we will represent like a comma 0. This will give you AB. What is this? Means this A, if it is 0, if this A, if it is 0, and what the answer we are getting? We are getting the answer A comma B. So let's see in the transition graph. A is going, if it is 0, if it is 0, where it is going? A and B. Let's see. A 0 is going to A. Okay, and again it is going to B also. Here also 0 and going to B. Okay, A is 0, A is 0 is going to A as well as B. So first we will do this, then we will see the graph. Next, A is 1, A comma 1. What is the answer? What we are getting? We are getting B. Okay, next, B comma, this B comma 0, B comma 0. What is the answer we are getting? B comma 0 answer we are getting C. Okay, B comma 1 we are getting A comma C. B comma 1, what we are getting? A comma C. Okay, what is the C? C is 0. What the answer we are getting? BC. When the C is 0, we are getting the answer B comma C. Okay, now the last one is C comma 1. C comma 1. What we are getting? We are getting the C. Okay, C is C when the input is 1. Okay, so this is a like you can write in this format also. A comma 0, A comma 1, B comma 0, B comma 1, C comma 0, C comma 1. So here, if A, till now we saw how to design the table from the transition table to graph. Now we will see this one. Okay, A comma 0, A comma 0, what is the answer? A and B. A comma 0 means is going to A as well as B. 0 0. Now the next one is A comma 1. A comma 1 is B. A comma 1 is B. How the answer we got this? This we got from this table, okay. So here the 1, if A is 1, then answer will be B, okay. Next, B0, B is 0. When we take B input is 0, then we are getting the answer C. So this 0 is there, okay. Next, B comma 1, then answer is A comma C. So B is 1, then answer we are getting the C as well as we are getting the A. So here like that, okay. Next is C. C comma 0 means is going to B as well as C. C is going to B as well as C, okay. Now C comma 1 is C. When the C, the input is 1, then answer is C. So this is one example, okay. I hope you understand this, and you can see small difference between DFA and NFA. In the NFA, we are getting the 0 comma 1, like whatever the inputs we have, we are getting all that, means but in DFA we will get only a single label. Here we are getting the two labels, like 0 1 0 1. It is taking any combination, whatever the combination you want, it will take and get the result, okay. So this is a NDFA. Okay. Now the another example, we will take the another example, okay. And here the graph is there, okay. And here A, where is the A? A is here. From the A, if the value is 0, from the A comma 0, where it is going, just check it. From A is going to 0, this is 1 A, okay. Now we will see the graph. Here we saw the transition table and we draw this. Now we will see the transition graph and we will write where it is going. We are generating the string, we can say, okay. A is 0, then it is going to A, and any other possibility, A to B, B is also there. Then A to C, C is also there. Then A to D, A to D is also there. A to E, E is also there. Is there any possibility now? 1 2 3 4 5, no, there is no any other possibilities. So close this. So why I am taking this A only first? Because this is a initial state, okay. Remember this. You will get the doubt like why you did not take C, B, D, E. Why I am taking this A? Because this is a initial state. In the graph, if you did not define the initial state and the final state, then it will be a difficult, and that is a wrong answer, okay. Now A comma 1, A comma 1, from A is 0, no, 0 0. Here A comma 1 is going to D, comma A comma 1 is E. Is there any other possibilities? No. So just close this. Now the next one is b comma 0. B comma 0. Let's see. From B, is there any going like here? Here it is going only. Only one is there. Okay. Only one is there from B to C. Only is C. Okay. Now the next one is b comma 1. Is there any possibilities for the b comma 1? Only one is there, that is E. B comma 1 is E. Okay. Next, take the C. Okay. C comma 0. What is C comma 0? C comma 0, is there any one? No. Only one output line is there for the C, that is only one. So here we need to write 5. 5 means empty. Okay. C comma 1. C comma 1 is only one is there, that is B. Okay. Next, D comma 0. What is D comma 0? D comma 0 is E. Only one is there. Okay, E. Then D comma 1. What is D comma 1? There is no, only one is there. Only one output is there from the D. So this is also a 5. 5 means empty. Okay. Next, E comma 0. E comma 0. E does not have any output string. Okay. All it is incoming. It is nothing output. So this is also a empty. And same as E0 and E1, both are empty string. Okay. So this is, while saying this, you can write this combination, you will get the string, or you can make in this format. Okay. Or you can make in this table, or you can make in this. Okay. So just you see here, simple thing. Okay. So this is a thing. So what is a formula? What is a formula? Like what I am doing here, a comma b. So here where here only I will do here, like here I will write the formula delta present states, present state comma, present state means whatever the state we have here, like A, we are taking A here, present state comma input symbol is this one, 0 or 1. Input symbol is 0, 1. Then you will get the next state. Okay. So this is a formula. So I will write here delta present state comma input symbol symbol is equals to next state. Okay. What is this? Next state. This is a next state. Okay, so quickly we saw what we have today. I am going to stop here. In the next class we will see some of the examples, okay, and we will solve that. So let's quickly review what we have done. Okay, what is today we have seen the non-deterministic finite automata, and here we will get the machine can move to any combination of the state in machine. So I gave you the example. I gave you the example of lottery. Okay, here I gave the example of lottery. In the lottery we will have the any combination and we will get at the final result, but till that we don't know, it cannot be deterministic. Okay, and politics, sports, war, and this all etc., this all are the come under in non-deterministic automation. Okay, formal definition of Ndfa is phi tuple q comma sigma delta q naught and f, finite set of state, and this is finite set of symbol called the alphabet, and here 2 to the power of q, because any how many symbols are there, how many states are there in q, that many possibilities will be there. Because of that is 2 to the power of q. In DFA we will have q cross x, q cross sigma is q, and here q cross sigma is 2 to the power of q, and initial state will represent as single empty state, and the final state will represent as double circle. Okay, and the graphical representation, in the graphical representation the DFA diagram, we can say the state diagram, transition or mapping. Okay, and this is what is represent the state, this what is represent as state, and labeled means when we are telling like 0 is going here, 1 is coming here. Okay, that is called labeled. Initial state is initial like this with the empty single incoming arc. Final state is double circle arrow. So we took the example. Okay, we had the q sigma q0 f. Okay, and with the help of this transition table we did this like present state comma input symbol. Okay, input symbol, then we are getting the next level, next state. Okay, what is the advantage of this? If you do this, then you will going to know which state will come after this. If we go in this, which state we are getting. Okay, so this is a transition table, this is a transition graph. Simple difference, but I will tell you in tomorrow class. In the next class I am going to tell you the difference between DFA and NFA. Okay, and we will do some of the examples. So here we took, while seeing this graph, we draw the transition function. Okay, we draw the transition function. So just I will write here transition function, FUNCTION, transition function. Formula is delta present state, we are present state comma input symbol, present state comma input symbol, then you are going to get the next state. Okay, so this is a transition function. So what we have done today we completed the we learn about transition table, and we did the transition graph, and we saw the transition function, FUNCTION. Okay, and this is important. In the next class we will see this some of the examples. Okay, and we will see the acceptance of the string, then we will see the differentiate between DFA and DFA versus NFA. Okay, thank you, and like and subscribe this for the more videos. Okay, fine.